Hello children. So due to some unavoidable circumstances, I did not make any learning videos for a long time. Hope you all are fine and good. So what you feel about my learning videos, please make a comment in the comment section. And if you like the videos, please like it. So you please tell us how to improve ourselves for further learning videos. In today's session, we will learn about one of the what important lesson for 10th standard students. The lesson name is constructions. So let us get started. In your previous classes, you have done certain constructions like you have used what instruments to constructions. Hope you all know that is you need an instruments like compass, ruler, and some divider, and you can say a protractor. So certain constructions like what bisecting what a straight line, angle bisector, perpendicular bisectors, some different varieties of what triangles. So you are being constructed in your previous classes. So in this chapter we should study some more constructions by using what constructions you made in your previous classes. And you would also be expected to give some mathematical reasoning behind why these constructions work. So in this chapter you will get three varieties of constructions. So just alright. Number one, division of line segment with respect to some ratio. Second one, constructions of similar triangles. Third one, constructions of tangents to a circle. So these are the three major objective of this lesson. Please note these ideas. So first one, division of line segment to line segment with respect to some ratios. This is a construction of similar triangles and constructions of some tangent. So here the three major keywords I am going to highlight. First one is something called ratio. The second one is a similar triangles, and third one is a tangents. So these three ideas, basic ideas I must know to understand this constructions lesson with an accuracy. So now let's get into let's have an idea about what is ratio, what are similar triangles, and what are tangents in basics. So now I'll start with what ratio. So ratio, I suppose if I got a ratio, it's a simple mathematical concept which is help us to comparing quantities. Just I will use often I will use the word simply how much to how much. This is a keyword if you use. So that is ratio is just a mathematical concept, just how much to how much. Suppose just I'll take a simple example. Suppose one kid having got 10 chocolates, another kid having 2 chocolates. So what could be how do you compare with a mathematical concept? I'll use something called is to. That is what you can say 10 is to 2. That is ratio will be 10 is to 2. That's further if you simplify it and both the numbers are multiples of 2. Because the 2 5s are and 2 1s are. The ratio of chocolates with respect to kid 1 to kid 2 will be what as a 5 is to 1. See how much to how much. That's what you can tell for the ratio. Now let's get to the second concept. As similar triangles. So similar triangles. So to understand this similar triangles in detail, you have a lesson you will study under there itself. But here I'll just briefly tell you what actually the similar triangles are. So if two triangles are said to be similar, so if the condition number 1, corresponding angles are equal, the second one, corresponding sides are in the same ratio. So please make these 2 points as in notes, because you must know what similar triangles actually. Suppose when you call 2 triangles as similar, just I'll draw 2 triangles here. Here I'll draw triangle 1, there I'll draw triangle 2. So just I will name this triangle as A, B, C. There I'll call it as something D, E, F. Okay. So 2 triangles I've taken. I want to predict whether these 2 triangles are similar. I will check the help of these 2 points to whether they are what similar or not. So now to see now the corresponding angle of A is corresponding angle here is D. The corresponding angle of B is, that is E. The corresponding angle of C is, that is F. Okay, just see now I marked 3 corresponding angles, and corresponding sides I am going to mark it now. The corresponding side of AB will be what? DE. The corresponding side of BC will be EF. The corresponding side of AC will be DF. You see now, just I mark the corresponding sides. Let's look for the what conditions what they have told us here. So if 2 triangles are said to be similar, first one, the corresponding angles are equal. So you can say, okay, if, I'll start with again the word if, corresponding, if angle A is equal to angle D, and angle B is equal to angle E, and angle C is equal to angle F. So on one more condition. So what is the condition? 2 corresponding sides are in the same ratio. The corresponding side of AB will be DE. So corresponding side of BC will be EF. The corresponding side of AC is DF. Suppose if they are equal, that's what is very important thing. Corresponding angles are equal, corresponding sides are in the same ratio. If these 2 what concepts are true, then you can conclude yourself those 2 triangles are similar, just like this. Therefore, triangle ABC is similar to triangle DEF. So you can look at the symbol. So this sign indicate for similarity. How to rate this one? Triangle ABC is similar to triangle DEF. So these what 2 keywords. So you must know to tackle the problems in what exercise first exercise problems to tackle. You need the concept of ratio and similar triangles. So now last, the third key point. You already aware of this. So let me once again memorize those ideas. Suppose you have a circle. Suppose you say, imagine it's a circle. If I draw some line, so with respect to some idea, suppose I keep on drawing straight lines here. The one straight line is just touching the circle at only one point. So you can say this line is touching the circle at only one point. Then you can call this straight line as a tangent. So formally I will define what a tangent is. A tangent is a straight line which touches the circle at only one point. The point where the tangent touches the circle, we can call it as a point of contact. So you need to take these 2 ideas now. A tangent is a straight line. A tangent is a straight line, touches the circle touches the circle at only one point. So this is a what a tangent is. So keep this what ideas in your mind. A tangent is a straight line which touches the circle at only one point. The point where tangent touches is called point of contact. So keep these three ideas. So this is the third idea will help you to solve the what the second exercise of the constructions. So now let's not waste your time. So let's get into the first concept of division of line segment with respect to some given ratio. And also to do the constructions, you just get ready with your instrument box. So you need a ruler in the beginning. So then you need a compass, and in some cases you need protractor too. So now I'll take first problem. So first one, divide a line segment with respect to some ratio. So first I'll take a straight line. Suppose line segment AB length could be around 8 centimeter. You just divide in the ratio. So the ratio, I'll take it as 3:2. Okay. So this is the concept. The length of line segment will be 8 centimeter, and divide that line segment with respect to ratio 3:2. So to do this one, I told just you need a ruler and a compass you need for this. So now, so you just start with yourself by taking what you just take a sheet of paper and take a ruler and draw a line segment of 8 centimeter. So I'll mark those two endpoints and just name it as AB. So after that one, at A, you need to draw a small acute angle, just like this. You can take whichever what angle you want it. It should be an acute one, like 30, 35, 45, or 6, or what will say 55, 60, like that. You just take approximately take. There is no fixed angle you should be taken. Just draw a what acute angle from at the acute angle should be projected at A. So after that one, just write the ratio here. I just have used it as something called M:N. That is 3:2 they have given. Just calculate M plus N. That is M plus N will tell us that just add those what values. Now 3 plus 2 you are having, that is 3 plus 2. That will be something 5. In the beginning you are trying to see now I'm calculating. I'm adding the what ratios in the first part and ratio in the second part. So just add them, you'll get 5 parts. So now, so approximately you just take take a compass and approximately around 1.5 centimeter, 1.3 centimeter. You just keep what cutting from A, just like this. So since you just see after adding you got 5, so you just cut this line into 5 parts, just like this. Use the what compass for this work. 1, 2, 3, 4, 5. So you just name this one as, you start with A, you just see called as what? A1, A2, A3, A4, A5. Just mark the what points. These points are very essential. Once you reach the what 5 parts, the finally you just join A5B. You just join this one. So I'm not using any scale there is. My diagram is bit what wrong, but if you use accuracy, just you can maintain that one. So now you just look at this one. Total 5 parts you have marked. Here the first part is 3. Just here you search 3 parts in the beginning. So here A3 you have. At this A3 you mark it. Now again you have to take the compass. Now take the compass, keep at A5. So just take the compass length something A5 to A4. So you can say more than A4 you take it. This will be a very nice diagram to get it. A5 to more than A4 something. So after this keep at A5, draw an arc like this. Again keep
keep at A3, again draw another semicircle. Now, just campus. So take the measurement, or take the radius from here to there, just like this. So just after this, take this spot measurement, you lift it up and keep it here and just cut it like this. Just because I have cut here in this. So that's what the construction. So now once you got this point, by using this point, we just draw a line from A3 towards the length AB. Just like this. So just mark this point as C. So if your construction is accurate, so these two lines should be the parallel line. So here you will observe 3 parts, here you will observe 2 parts. So now the line segment has been divided into so ratio 3:2. You will observe 3 parts here, the 2 parts here. You can measure it or you can write the lengths also. Suppose the length of AC you measure and write it here, and length of CB you measure and write it there. So this is what the division of line segment to with respect to some ratios. Just see now repeating here the what confusion part is so simple. Just given the what ratio, just add up them, find how many parts you need to draw, just mark the points A1, A2, A3, A4 and A5. So later on you just draw the last part to the last end of the line segment. Then which part you want to cut it, just fix in first one. So 3 parts, at the 3 parts you need to draw a parallel line just like this. So from here you just take some radius and draw an arc or draw an arc there. Okay. After drawing the same, just keep at A3, draw another arc, a semicircle, then measure this radius and keep it to this point and cut that one. At last you get a point. Via that point, which is from A3, you just draw a line segment towards AB. Finally you get a parallel line. So keep your mind, don't forget this. This should be a parallel line. If they are parallel lines, so you get an accurate result for this constructions. So now I'll take over another type of construction, something construction of similar triangles. So just I'll take help of reader. So then only I'll construct it. Here the question goes like this. Construct triangle of sides construct a triangle of sides 4 centimeter, 5 centimeter and 6 centimeter, and then a triangle similar to it whose sides are of 2/3 of the corresponding sides of the first triangle. So first one, I need to construct a similar triangles by using single triangle here. So they have given some ratio here. So this ratio is considered as a scale factor. So you can say to construct the triangle, I need a scale factor to perform this. So now, briefly, let me take the scale factor first. A scale factor, that is 2/3. You can say ratio of corresponding sides
So you can say ratio of corresponding sides is also called as a scale factor. With respect to the scale factor, you need to construct a similar triangles for this. So most of the this is some bit different compared to the division of line segment. So first let me fill the first task, construction of triangles with a different length. So usually base will be taken with what larger what length. So since 4, 5, 6, 6 is a larger length, just base length just take 6 centimeter. Draw a line segment of 6 centimeter. So now this is A and B you call. Okay, AB just this, since they have not what named the triangle, you can name it by yourself. So AB length I have taken as 6 centimeter. Then take 4 centimeter radius. So keep at A, you just draw an arc. So usually the first arc should be bigger one. So then take a radius of 5 centimeter, keep at B and just cut that arc. So after one, if to join this one, you will get a beautiful triangle AB. You can name this as what? C for this. You have a triangle here. For this construction, for this triangle, you need to construct another similar triangles with a scale factor of 2 by 3rd. So now you just draw an acute triangle at A, just like this. So now here the ratio they have given 2 by 3. So here the scale factor. So in the beginning, you just search the what denominator portions. What we say? So 2 by 3 you have the fraction. So denominator could be 3. So what you have to do? How many parts you can make it? So that should be the what number you can observe in the what denominator portions. So there are 3 parts. You just make 3 parts here. As I told, around 1.5 or 1.3 centimeter. If you take it, it's well and good. Don't take 1 centimeter. It will be very congested. So around 1.5 centimeter take. So use a compass for this. Here I'll take this. So 3 parts I will make. 1, 2, 3 parts. You name it as what? A1, A2 and A3. So finally, you just join A3 to B, just like this. Hope you remember what you are doing in the line segment. In the line segment, you are adding the ratios. A ratio of first part and what? Second part. But here you shouldn't add what the denominator portion will get. Suppose 2:3 or 2, can say next part, the denominator part, how many parts you get that make this, you just make those 3 parts there. So they 3 parts, 5 parts like that. So after that one, just find 2 parts here. Here there is A2. For at A2 I need to draw a what? A parallel line. The procedure is same. Just now take some radius of what A2. More than A2 if you take it's well and good. So just draw an arc to let it meet the both the lines. Keep at A2, again draw the semicircle like this. So after that one, you just measure this line. So measure this, take this radius by using compass and lift it up and keep it this point. Okay, so then from A2, you just draw the line, a parallel line. So somewhere I missed it. So I am balancing because I need to get a parallel line that is. So at A2 you just draw the parallel line. Okay. So after that one, again do the same thing from this point. You just call this point as B dash. Since you have taken B here, you call this point as B dash. So now at B dash, draw another parallel line using the same strategy. So now just see now take this one radius. So again you can just take this something what radius at B, again keep at B, again draw like this. Take this one, you just cut this one. At B you just draw another parallel line. So I'm adjusting. Just have a look. So this is what the covered construction of similar triangles. So on the triangles you can name this one C. You can name it as what? C dash here. A. You can say, oh, it's the time to write the what ratios and the what similar triangles. So scale factor is 2 by 3. Then I'll just write this one. So you can see since
AC dash, so you know AC dash by AC is equal to AB dash by AB is equal to C dash B dash by CB. Both are equal to, all are equal to the 2 by 3rd, but this was a ratio. So therefore triangle AC dash B dash, AC dash B dash is similar to triangle ACB. So I know that is because I have not used the instruments, so the you get an what result like this. So in my next video I will try to use the what instruments to elaborate more about constructions, and in my next video I will try to use the what instruments, and also these two concepts are what helpful to tackle problems in the exercise exercise, first exercise of the what 10th standard constructions lesson. So now, so what you people have to make, you just take these ideas what I what use this. So now you try it by yourself for the what to solve many problems or more problems on this concepts. Thank you.